So I guess I have like have what like 25 minutes or something. So what I'm going to do is I will talk about something that is like relatively simple that the objective here is I'm okay. The problem is like we are trying to do some shape detection. Like let me this one that's it's not working. Let me just start sooner again. So let's say I want to do shape detection. Let's say I have an image here or video or whatever. So I want to detect some simple shape. So let's say maybe I want to detect circle or detect a line or detect some regular shape, maybe even a square, something like that in the image. So the the technique here is a pretty old, but it's a quite useful. It's known as this Hough transform. So the idea is actually simple. Like let me just take circle as an example. So let's say I want to find circle on in the scene here. So let's say like I have an image here. So and let's say you use say some maybe uh corner detector or like whatever like anything that just get the or edge detector to get the outline of the image. Maybe you start with the image, maybe like have something have a hat here, like someone, and then maybe holding a stick or something. Like we want to recognize the hat or whatever. Okay, and then um then maybe I do a edge detection. Like okay, at the beginning maybe they have some colors, right? So I have some colors and here and so on and so forth. But then after edge detection, I only get the outline back here. I only have the outline. Now I want to do maybe detect for example like of course this is very primitive if I try to detect face using this. But let's say if I maybe another example is that I just have a bunch of cons here. Let's say I have several cons here. They are very circular, almost perfect circles. And I just want to find the location of those cons. So and in that case, using Hough transform will be very suitable. So basically, the precisely what Hough transform is trying to kind of like as the name suggests, as some kind of transform, right? Is transforming an image from a kind of like this domain with like pixel domain. Like first of all, like after like I do this kind of like edge detection to get the outline. Typically, what I can do next is I do a thresholding even. So I do a thresholding. So therefore, like now what I get is basically like for the outline here, I will just say one, and for all the rest, I will zero. So I will have just like a mask here, like an image mask here. So it's like just take value like zero or one, basically. So for 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 this like outline here, like will be one, let's say, like for the rest will be equal to zero. Now, um, I'm going to do this Hough transform to transform this image into some what I want to say a parameter domain. So you can think of like this is very general thing. So I have a parameter domain that depends on the shape you are kind of like estimating. It can have like different kind of parameters. So for example, if I have circles, let's say if I have circles, then just one circle, let's say one circle. So how can I describe a circle in general? So in general, let's say like if I say like I want to specify precisely a circle, then I need to kind of specify the location of the center, right? So I have like X and Y basically specify the location of the center, let's say. And also I want to specify the radius. Let's say R is radius here. So then I have three parameters, right? So basically um I for any circles, I can parameterize by these three parameters like X, Y, and R here. X, Y are the center, and R is the radius, right? So let's say like let me simplify it even. Let's say I assume the radius are all the same. Let's say the radius all equal to 1. So then in this case, or like in this case, let's say like maybe not 1, maybe equal to 10, let's say 10 pixels. So something like I'm looking for circles in this scene here. Like I already know that like all the circles will be like have radius 10. So then my parameter space kind of like uh can reduce a little bit, right? So we'll be only have like two parameters now, only the x and y location here. Now to find the circles like in this scene here, what we can do is like we go through like each pixel at a time. Now, if I go for like let's say if I let's say let me just take this one. Let's say for example, like if I know okay, this is a circle that with radius 10, right? As I said, like, I know all the circles here with radius 10. So now if I look at like each of these pixel, like maybe I have some also like some other dots here, like maybe I do this edge detection and corner detection is like not completely clean, right? Besides this circle. And also like most likely like it's not so ideal. Maybe I only have this circle segment, something like this, right? So and with let's say I just scan through the entire image, and then I let's say I take any particular points that is non-zero here in the mask that's non-zero here, that potentially can be an edge of a circle. Now, if I think of a point here, just for this point here, so it can be oh okay maybe I make it as a question. So now let's say I guess it's difficult to make it a question. Maybe not now. So now let's say I have this point here. Like you say that particular point, I call it like uh maybe just give a precise point here, like 100. Like this is the location of the point here. Now for this point here, it can be a point on a circle, and it can be a point on a circle. Let's say uh wait, I guess I can make a question like that. Like the question will be like, if I have pawn like this, um, I can claim that this can be a pawn on a circle with the location of the center 90 and question mark. So what was the question mark here? This is the center of the circle. So should I repeat the question again? Like I have like a a pawn, let's say, let's just consider the radius. Oh yeah, radius is 10 here. Radius is 10 here. So then like just for this particular point that's 100. So given that I have the point 100 here, it can be a point on some circles, right? So actually on many circles. I mean, particular only care about the circle that like, let's say with the x coordinate of the center is 90, then what will be the y coordinate here? Oh, be careful for that. Yeah. So uh, if x is 90, y is 90, then what will be the radius? Like if it, um, so anyone else are here? I guess after the presentation, most likely everyone is gone. So I guess okay. Let me yeah. So this will be just be 100, right? Yeah, because yeah, right. So you have so basically if I have a point here is 900 let me just zoom in more. Let's say this point is just make it less noisy here. So let's say I have a point here, it's like 100, right? Now this can be a point on a circle with center here, right? 1900, right? If I have a circle like this, then the radius is 10, right? So therefore, like this point 100 should be fall on this like circle 1900, right? Yeah, of course, yeah, sure. Yeah. So now you can see that like actually if I given a point like this, it you can just think of like what kind of circles can contribute to a point like this. You will have like many circles contribute to a point like this, right? Basically, precisely the the location of the center that contribute to this point here is precisely a circle with radius 10 and the center 100, right? So basically, I can have like this doesn't is not drawing very well. Maybe I try to draw it again with the help of this one. Maybe let's see. Use this in color. Does it make a circle? Okay, great. Yeah. So right. So basically, like I will have like if I consider this point here, the center or like you can think of the perimeter of the circles that can include this point will be basically a circle with the center here, right? So now you can think of like now if I can if I have more such points here, let's say I have like not just this point here, but I have like also this point here, this point here. So for this point, I also make another circle. Right? This point, I make another circle. Right? So if I have like, let's say the original circle is indeed is here, let's say 90, 100 here. So then maybe I have some kind of like segment of the points here, like for this is basically on the parameter. Is a parameter? No. What's that called? Like circumference? Or yeah, I guess it's that. No, I don't know. Anyone can help. I don't know. So, but anyway, um, of this circle or the boundary of this circle or the edge of this circle. Okay, sorry. Like uh, uh yeah. So then I can just add all this for add all this contribution up, right? So if I have this one, the potentially circles that can include this point here will be on this circle here, right? So if I consider the next point, the potential one will be something like this, I guess. Oh, so I cannot draw another good circle. Yeah, that's quite a bit off. Um, maybe I should try again. Still difficult, but anyway. So then I continue to take care of all of them, and then basically I add all of them together. Then what you get is that you will get a peak at that location, right? So maybe I would just better to illustrate that like using I think I have somewhere here. Yes, where is it? Let me pull just where is that? Yeah. Okay. Yeah. So it'll be something like that. So as I said, like let's say this is two circles here, right? So it doesn't look like very good circles here. But let's say if I can't like if I look for like the circumference, is that really circumference? Let me make sure. Okay, circumference is the length, right? Yeah, perimeter is wide. I am confused. Okay, circumference. Yeah, along the circumference of the circle, if I just add all this together, right? Basically, if I consider this point here, let's say at this point here, I draw a circle, and at this point here, draw a circle, and add all of them together. So when you sum over the entire thing, then you will get the total contribution will be like this, right? Now then, essentially the point that have the maximum activation will be the center of the actual circle now. So in the sense, it's really a voting process. So you take for each of the non-zero points, say in the original image, and then you think of like what kind of parameters that can contribute to this image. Contribute to this non-zero point here, and then like you give a role to that parameter, right? So in that parameter space, so I can think of like this. Yeah, I mean, like if I think of like uh, the center, let's see, what should I say? I have the parameter space of the circle here. Okay. I hope I. So you can think of this. What I want to say is this is like you can think this is like the parameter space, and you have high activation correspond to like high likely to get a circle with that parameter. I mean, in this case, the parameter is just the location of the center. So therefore, you have like two centers, something here. That I have the original circles here, and then I have this basically high activation at the center of this two circle here. So of course, this is I can imagine this is a simplest example, but this idea can extend to any kind of shape. But of course, it depends on like the number of parameters you have for the shape. You get easier or like, or I should say, it will get like more and more complicated if you have more parameters. Um, for example, like if I consider line, this is an example for a circle. So if I consider lines here, let's say if I want to look for lines in an image. So let's say if I have an image and I want to look for like any potential lines here. Again, I can start with like any image, and I can think of like, okay, I'm going to take a uh, first do an edge detection or something, like just get the points here and then do threshold, and more or less I get a line, something like that. So now for every point, again, I will go for each of the points here that is can potentially contribute to a line, and I will try to see like what possible lines can go for this point. So if I have point here, then I may have a line like this. I have made a line like this. May have line like this, right? All this can be a line, can be lines that like include this point, right? And then like for each of these, I will basically in the parameter space. So then I can go into a parameter space. In this case, my parameter space can be like the two axes can be like one is theta and one is L. Let's say my theta L will be like defined this way. Like maybe I start with like this as a 0, 0. I can define a every lines as something like that. Maybe like let me take a 90 degrees here. So every line defined as a this with this theta and this L here. Right. So any line can be defined like this, right? Any line in this let me draw a bit better for this one here. Yeah. Now, so for given a point here, then I will guess basically for different theta, let's say theta from 0 to 50, 60 degrees. And as I change this theta, like from 0 to 360, then I will have different L, right? Potentially, I guess the L will be like sinusoidal or something like that. And I guess only have one, probably it's just something like that. And then like for another point, maybe I consider another point here. Then also like um for different theta, then I will have like different contribution for different L basically. So, or like, let me repeat this. If I consider this point like a different point here, then again, I can think of like what kind of lines that can potentially include this point here. And the lines that include this point may be, in this case, maybe something like that. Let's see, let me draw something like that. Maybe something like that. Maybe then like I will have another one, like consider another points here, then I may have something like this. And then eventually, again, like in the circle case, if you consider all the points here, you have like some point on the on the parameter space that is like highly activated, and that will be the parameters of the line. So for example, like eventually I will have this line here, like this one, will have like theta is equal to 45 degrees. I say L is like 10. And I will have the point here will be like highly activated at this like 45 degree and L equal to 10, something like that. So is that is that clear? Uh and of course, as I said, like you can basically use Hough transform to um, detect any kind of shape as long as your shape can be um, parameterized somehow. For example, I can also use that to estimate or like to detect like squares. So squares would be a little bit maybe like squares. Let's say let me give this another question. So just to end it here. So let's say I have a square. Say I want to detect squares, and with the width and height of the squares is 10 here. And now let's say if I have a point, let's say somewhere, uh, let me I'm going to uh, parameterize these squares, and the parameter space we'll be using is let's say okay, this may be I need to specify how the access goes. Let's use the usual Euclidean kind of like coordinate. So Cartesian coordinate. So I have like x in this direction, y in this direction. Instead of the computer graphics, usually you have y going this way, right? So let's say I specify x is this, y is this here. And I'm going to parameterize any square with its lower left corner here. So let's say like for this square here, let's say if the corner here say is 100 and 100, then the parameter for, or let me change it differently, maybe 110 and 100, then the parameter, so maybe I can call this a uh, okay, I use x and y here also. So then in the parameter space here, so if I have a square like this, so you expect a high activation at somewhere like let's say 110 and 100, right? So I will have a high activation exactly here, something like that. Now, so let's say if I have another square now, I have a square. Uh, okay, maybe I just say like if this square uh shifted by like 10 pixels. So if I move by 10 pixels, uh, where should this point move like in the parameter space? Like shift left by 10 pixels. Yes, shift left. So my new square, let's say is here. Yeah. No. I, the question is like what should be okay. The question is like what uh what is the, or like I should say where Oh, I'm sorry about that. Yeah, yes, sure. This is white. I can't even differentiate why I'm not. I definitely not have enough coffee today. Yeah, yeah, it's shifting to the shifting to the white. Yes. So okay, the question is not left and white. Uh, the yes, that's good, good. The question is like, what is the where is the pawn changes like in the yes, yeah. I guess this is obvious, right? So okay, I guess I'm not going to. Yeah, this is just a high level understanding of Hub transform. If yeah, yeah, basically you can derive your own like for any Hub transform. I guess if you understand like this. So I
Professor
guess
Chen, I have a
yes,
question.
yes,
So this parameter 110 and 100 is indicating the one corner, right, of the square.
yes,
But what if we have another square with a different size? How can we
yes.
parameterize of that
Yes,
different?
I make it a little bit simpler. So
Uh-huh,
if you have a square of different size, you have the
uh-huh,
third dimensions here. Basically, you have the let's say d is the size of the. Then your half transform is actually three dimensions actually. So therefore, it's a little bit complicated to draw that. Therefore, I didn't go there. So then you can think of like for any point, like for any point, you can think of like what square or what parameter of the square will can include that point, right? So
mhm,
then in that case, I actually you can think of like this. I have another access here is D here, right? This is like only for D equal to 10, I will have like a point activator here. So, but I will have like, let's say when D equal to 20, let's say, uh, I need to specify which point I'm looking at. So let's say if I'm looking for, let's say I start with this point here, right? If I start a point here, let's say this is the location here, say 120 and 100 here. Now, as I mentioned earlier, if I just consider this point here, the square that will include this point with the width and height of 10 will be have the corners, like the parameter of the corners will be 110 and 100, right? Something like that. Now, but if I consider like a different d here, now if a different d, let's say d is 20, then the corner to include this one will become this square, right? So now the points here instead will be here now.
mhm,
So therefore, like for d equal to 20, you have somewhere here
mhm,
190.
mhm,
Yeah, so it's like you if have like also detect like for different size of square, then you will have a three-dimensional transform. Again, you will go for all the points here in the space that is non-zero. There's something like non-zero. Then you will just add all of them together. So for each point, you will have some activation in this three-dimensional space, right? And then you consider another point, you have activation in the three-dimensional space as well. Then you add all of them together. Then eventually you find like which one is the peak. Then the one with like maximum activation will be the parameter. Yeah.
I see.
Yes.
I see.
But
Thank
yeah.
you.
Yes. Yeah. So okay, I guess that's it. So yeah, I will see you guys like next week then. Yeah. Uh
I have a question.
yes, please ask. And about like I see there's sorry, like there's a way to present. You yeah, you shouldn't submit until the I don't know whether you can resubmit. If you can resubmit, probably is fine. You because like we still need to yeah, if you want to like fill in like for now and submit, I guess it's fine. I think it's you can resubmit. So wait, I guess when you resubmit, it's that you probably need to fill in again. I don't know. Um, So okay, like someone has a question, right? So what's the
Yeah,
idea?
for the progress report, you don't have a link on there yet. So, are you gonna put one for the
Uh,
progress report?
say it again. Do
The
we
progress,
don't have like what again?
they don't have a link for the progress report to submit.
Oh, okay, that probably a mistake. Let me take a look. Like yeah, if it doesn't have one, then definitely it's a mistake. Like we should have uh yeah, okay. Yeah, thank you for letting me know. S- so we just added that. Like you should be able to. Yeah, I think you should be able to submit now.
Thank you.
Yes, sure. Uh, and so any other questions? So I guess if not, I will see you guys like next week then. Yes.